Hello friends, the next topic in JFET is transconductance of JFET. This is another important, very important topic of this device, that is JFET. The transconductance of JFET is defined as the variation in drain current with respect to voltage VGS at a particular value of the VDS. When VDS is fixed, the variation of drain current with respect to gate to source voltage is called transconductance. We know the drain current of JFET is equal to what? IDSS into 1 minus VGS upon VP whole square. That's what you have. If you differentiate this ID with respect to voltage VGS, you will get what? That is 2 IDSS by minus VP into 1 minus VGS by VP whole. That's what you have. Fine. But remember, this is what? Transconductance. Therefore, the transconductance of this will be equal to 2 IDSS. VP for this will be negative, so I will say pinch of voltage magnitude, instead of negative sign, putting negative sign here, pinch of voltage is negative for this. So, this is equal to 1 minus VGS by VP magnitude. This expression is very, very important. You must remember this. Or you can say this can also be written like the GM equal to GM naught 1 minus VGS upon VP, right? Say this is equation number 1, this is equation number 2, this is equation number 3, where what is this? GM naught. This is the transconductance 2 IDSS by VP magnitude, that is transconductance when what? At VGS equal to 0. When gate to source, this is shorted, gate to source terminal is shorted, this becomes 0. So, GM is nothing but GM naught. Fine. This is one expression of the transconductance. But if you see from first equation, what do we get? 1 minus VGS by VP is under root ID upon IDSS. Putting this expression in equation number 3, putting above expression in equation number 3, what do we get? We get GM equal to, you please see, that is 2 IDSS upon VP magnitude multiplied by under root ID upon IDSS, or this gives 2 IDSS into ID under root divided by what? Magnitude of pinch of voltage. This is another expression of the transconductance which is very important. You must remember this, you must remember this. These are the expressions of transconductance of the JFET. Let us take a small example based on the transconductance of JFET, which have appeared in this question has appeared in past. What was the question? Let us see. Question is, in n channel JFET, IDSS is equal to, that is given to you, 2 milliamperes. Fine. Then we have pinch of voltage of the JFET is minus 4 volt. Transconductance of the you have to find GM transconductance at VGS equal to minus 2 volt. When VGS is minus 2 volt, you have to find the transconductance. And we know what is the transconductance? That is equal to 2 IDSS upon VP magnitude 1 minus VGS upon VP whole square. That's the simple formula. This is 2 into 2 milliamperes. Vp mode of Vp is what? That is minus 4 magnitude. 1 minus minus 2 minus 4 whole under root. So this gives that many millimho. Why? Because this IDSS was in milliampere, so I have written that in millimho. So this gives what? 4 and 4 will be cancelled out. This is 1 by 2, minus 1 minus 1 by 2 is 1 by 2, so that is 1 by how much? I am sorry, this is not square, this is not square. So this is equal to 1 by 2 millimho or millisiemens. 0.5 millimho or millisiemens is same thing. So this was the question which appeared in GATE in 99, 2 marks question. But there can be numerical based on this formula in engineering services prelims. Earlier it was in the syllabus of GATE, that is why I have talked about the question from GATE. But now this is no more in GATE syllabus, but there can be a question in engineering services prelims, or maybe numerical in engineering services mains, or maybe numerical in civil services mains exam. So this is all about your transconductance of the JFET. And now in my next video I will be talking about, that is, the small signal model of JFET. So just wait for my next video. Thank you very much for watching the video.